Hello and welcome. Last session before the drinks, so I will do my best to stay in time. So my name is Andreas Schuetz. I'm a sales engineer and data scientist from InterSystems Germany. And today I want to show you how you can use InterSystems IRIS Interoperability to integrate large language models in your applications. And I want to mainly focus this talk about the integration part. But before I jump to this, I briefly want to discuss what is required to build a large language model-based application. So the first thing that we need to do is we need to choose a model, especially a model that fits our budget. Because when you're using cloud services like GPT-4 and you use pay-per-use models, this can add up and get quite expensive. So keep that in mind when you want to build a language model-based application. The next and probably most important step is to find a prompt that is able to solve the task we want to solve using language models. Basically, you can say the better the prompt, the better the output is that the model will give you. And the last part, especially when we want to be able to integrate the language model output or to process it in an application, we need to find a way to extract the relevant part from the output. So let me explain what I mean by that. Here's a quick example. So let's say we want to use a language model to do translation. And what we could do is just ask a model like ChatGPT, what does Bilderrahmen mean in English? And the model tells us Bilderrahmen is a German word and that it translates to picture frame. So for a human being, this is a really good output. But as I said, if we want to be able to process the output in our application, we need to find a way how we can extract the relevant part from the output. And what we can do is we can, in this example, a little alter the prompt and add a small instruction like only output the actual translation. And then we get the output we want to have. So this is really simple in this case, but you have to keep in mind we're using a very powerful model. I used GPT-4 for this example, and powerful models or capable models make prompt engineering really easy. But what if we don't have the budget or we want to use a smaller model? So I installed Llama 3 on my local machine. It's a model you can get for free and run on your own hardware. And I used the same prompt. I used the same input. And this is the result I got. So as you can see, it doesn't really contain the output we want to have. It doesn't contain the translation. And it seems like the model didn't understand our prompt. So we need to put a little more effort into the prompt engineering. And a simple yet very powerful trick I want to show you is to just add examples to the prompt. So those examples can always stay the same. And then at the end of the prompt, we add the actual input we want to translate. And now let's have a look at the output. And as you can see, now we get the translation, at least in the first line. So there's only one step left. We need to separate the useful output from the model hallucination. And this can be done really easily in this case, because if you have a close look at the left side on the prompt, it's following a pattern. It's always input English, and so on. And the model is keeping this structure when generating the output. So it's really easy to separate the useful part because we can just look for the first line break, use a string operation, and only use the first part from the output. Okay, so now let's have a look how I did the integration using our IRIS Productions. Okay, can you still hear me? Yeah, perfect. Okay, so as I said, I prepared a demo for today. Are you able to read it? I can zoom in a little more. Okay, so this is the production I created for today to show you how you can implement language model applications using our productions. On the left-hand side, you can see a service. It's a REST service that can be used by client applications to call our language model-based services. And let me show you really quick how this can look. So this is one example service I implemented. Here you can see the demo is running on my local machine. This is my actual web application, and the end of the URL is the actual service I want to call. So this is a sentiment analysis service, and what it will do is when I send input to this service, it will return if the sentiment of the input is positive, neutral, or negative. So as you can see here, this is a movie review, and it's telling us the movie is the best movie in history. And the API, the REST service, tells us, yeah, the review is positive. And we can also do a negative example. So this is actually a review from the same movie, and this review is telling us it's absurdly overrated. And the response, as you can see, is negative in this case. So let's have a look what's happening in the background. So the REST service is connected to an app router. And the app router is using our rule engine to determine the right service, the service that we actually want to use. So you can see here, I implemented 3 applications. I implemented a translation application, a sentiment analysis endpoint, and a chat endpoint. And if I want to add additional applications, I can simply add a new condition to the rule and do some copy-paste. Okay, so the next step is the business process. That is combining all the operations we need to call and to generate the output. You can see it's connected to 3 business operations. The first one is my prompt operation. I created a really simple class and called it simple prompt operation. And what it does, I can define a template, a prompt template, and I can define a placeholder. And when this operation is called, the input will simply be replaced by the input that I gave to the REST API. The next step is the model operation. So I added 2 examples here. One option is to use a cloud service, like we heard by Ray in the session before. And this was really easy to implement thanks to embedded Python, because I could simply use the official Python libraries from OpenAI. And if I want to change settings, for example, instead of using version 3.5, version 4, I can simply select it here, hit apply, and now my operation is using GPT-4. And the last step is the extract operation. We don't see a lot of settings here. That is because I decided to make it configurable via the request message. So let's have a closer look at the prompt, at the business process. There it is. It's a little bit difficult because of the zoom level, but here we are. So as you can see, the first step is to call the prompt operation. Then I'm calling the language model. I can add a few settings, like the maximum number of tokens I want the model to generate. I added the sampling settings. And the last step is to call the extract operation. And what you could do, what you can see here, is to add expected values to the extract operations, so I can check if the model output is actually what I expected, or if the model output is valid. And I also added some additional functions like stripping punctuations or lowering the output. And now we can have a look at the message trace. And here we can see the way of the message through our production. So this is the request that came via the REST API. Then we're calling the prompt operation. And here you can see it's adding the input into our prompt template. Then we're making the request to the model. This is the response we got. You can see we get some additional information that I didn't use for my web service right now, but we could use it, like the timestamp when it was created or the tokens that it used to generate this output. This is useful if you want to keep track of the costs of your model. And the final step is, like we just saw, extracting the output. And the extract operation also tells us the response is valid, because the model response was, like negative in this case. And the extract operation in this case is really simple. Of course, you can also have more complex processes. For example, for the translation service, I added two prompts and two model calls. So one model call is to detect the language, the source language, and the second model call is to do the actual translation. And because I'm using a local model, the llama model, like I did in the example in the beginning, I needed to find or to put a little bit more effort into the prompt engineering. And therefore, I decided to use the sampling method. And I stored the samples in a database, and I created a prompt that is able to get the data from a table or from data stored in the IRIS data platform. So this is also possible, of course. And notice, so far, I haven't used a single line of code. So of course, I had to create the operations once. But now with the setup, I'm able to create language model-based applications without having to write a single line of code. So let's have a quick look at the other example. You will notice it's taking a little longer. That is mainly because this is a MacBook and I'm able to use the graphics card to do the output generation for the local model. But if you're using like a Windows or Linux hardware and you're using a graphics card, you can expect really good performance from running a smaller language model on your own hardware. As you can see here, in the meantime, we got the response. So here you can see the actual translation from the input. I don't speak Spanish, so I can't really verify it, but it looks right to me. And it also gives me the information, what is the source language. And if we call the same endpoint a second time, you can see it's much faster now because the model is already in the memory and therefore it's way quicker. Okay, so there's one last example I want to show to you. And this is the chat endpoint. So this is, of course, a really simple chatbot implementation. And I can ask questions like, what do you think of InterSystems IRIS? And as you can see, we get a pretty extensive answer, like you would also get from, for example, from calling ChatGPT. But now we are in control of the prompt. And so we can change the prompt. For the request I did right now, I used this prompt. You're a chatbot named Bob, answer as helpful as possible. And then I'm just giving it the model a little bit of example input. And by simply changing a few words, this is what I did here, from answer as helpful as possible to answer as short and precise as possible. Let me show you what it does. So I will quickly change the prompt. If I find it, there it is, the business process. So now I can simply select that I want to try a different operation. So instead of the regular chatbot prompt, I'm using the short one. I click apply, I compile. And now if we call the same endpoint again, you can see we get a much shorter answer. And you could also do this, for example, based on the user who's making the request. So for example, in a clinical environment, you might use a different prompt depending on, let's say a patient is asking the question or a clinician. So a patient might want a simple explanation and the clinician is interested in something like this, in a short and precise answer maybe. Okay. So I hope you saw it's not too complicated and actually quite easy to integrate large language models into your applications, especially when you're using the current generation. So this used to be way more difficult. When the language models haven't been as powerful as they are now. Okay, so now is a good time for questions. Do you have any questions? Okay, yeah. So I have only 2 slides left. Please do the survey you can find in the Global Summit app. We really want your feedback. And if you want to get in touch with me, just feel free to talk to me here at the Global Summit or send me an email or contact me on LinkedIn. Thank you very much. And now let's enjoy the Demo and Drinks event.